Hello students, by this video let us study the physical properties of the 13th group elements in the periodic table. So what are the elements present in the 13th group? So the first starting element is boron, B, aluminium Al, gallium Ga, indium iron and thallium Tl. So these are the 5 elements present in the 13th group. Because boron is the first element in this group, so the group is named itself as boron group. And the alternate name for this boron group is isotope. Now by this video, let us analyze the physical properties of each element. So first, let us look at the atomic number of boron. Boron atomic number is 5. So based on the atomic number, we do write the electronic configuration. So what do you mean by electronic configuration? So electronic configuration is the distribution of electrons in the orbital in accordance to the Aufbau principle, Hund's rules and Pauli's exclusion principle. So all these principles we have already studied in our +1. So now we are not going to say about it. Now we will see how the electronic configuration is written here. So boron atomic number is 5. So for this 5 we do write the electronic configuration short form as helium 2s2 2p1. So why do we write helium? Because the atomic number of helium is 2. So instead of writing the configuration of instead of writing the 2 electrons, we just represent the 2 electrons as helium. Yes? So helium 2s2 2p1. So helium 2, 2 plus 2 4, 4 plus 1 5. So 5 electrons every time. Yes? Now next we will say aluminium. Aluminium is 13 atomic number. So how do we write the electronic configuration? Neon 3s2 3p1. So neon we write in the bracket because the neon atomic number is 10. Yes, number of electrons in the neon is 10. So 10 plus 2, 12, 12 plus 1, 13. So 13 is the atomic number of aluminium. So the short form or the short representation of the electronic configuration of aluminium is neon 3s2 3p1. Likewise gallium it is 31. So argon 3d10 4s2 4p1. Argon atomic number is 18. 18 plus 10 28. 28 plus 2 30. 30 plus 1 31. Okay. Now likewise indium. Indium it is scripted 4d10 5s2 5p1. So like this scripted it is 36. 36 and likewise 36 plus 10 46. 46 plus 2 48, 48 plus 1, 49. Okay. Now thallium. Thallium atomic number is 81. So how do we write the electronic configuration? Xenon 4f14, 6s2, 6p1. Yes. So here xenon, it is atomic number is 54. Next let us study the physical state of these elements. Now boron, how does it exist? So we know matter exists in 3 forms: solid, liquid and gas. So in the case of 13th group element, boron, aluminium, gallium, indium, thallium, all these elements exist in solid state. Fine. Now the next property is isotopes. So isotopes, what is the definition for isotope? Isotopes are the elements having same atomic number but different mass number. Okay. So for all the elements in the 13th group, there exists one isotope for each. Boron B11, that is the isotope. 11 is your mass number. 11 is the mass number. Okay. Likewise for aluminium, one isotope is existing, that is aluminium 27, gallium 69, indium 115 and thallium 205. So each elements are having single isotopes. Okay. Now next one, the atomic mass. So atomic mass, the unit is gram per mole. So atomic mass is the mass of the atom. Okay. Now in the case of boron, it is 10.81 atomic mass and 26.98 in the case of aluminium, and the atomic mass of gallium is 69.72 and indium it is 114.81 and thallium it is 204.38. So that's it about your atomic mass. Now next one is the atomic radius. So atomic radius unit is Armstrong unit. So what do you mean by atomic radius? So atomic radius is the distance between the center of the atom, that is the nucleus, and the outermost valence shell. So that distance is nothing but your atomic radius. Okay. So for boron, the atomic radius is 1.92 Armstrong, aluminium 1.84 Armstrong, and 1.87 Armstrong unit for gallium, and 1.93 Armstrong unit for indium, and 1.96 Armstrong unit for thallium. Fine. So that's it about your atomic radius. Next comes the density. So density, you know, mass by volume. Yes. So its unit the density of boron is 2.34 and aluminium 2.70 and gallium 5.91 and indium 7.31 and thallium 11.80. So while coming down the group, all these atomic mass, atomic radius and density, yes, density, they all are increasing while coming down the group. But in the case of atomic radius, you can see boron atomic radius is 1.92, then it is decreasing. Decreasing, it's not an increasing, it is decreasing. In the case of aluminum and gallium, that a slight difference is in the case of atomic radius. Then from gallium again it is increasing S to thallium. Okay, so a deviation is seen from boron to aluminium, then aluminium to gallium. From boron to aluminium it is decreasing S, and the gallium also slight difference is seen in the atomic radius, and then from indium to thallium it's again increasing. Okay, now in the case of melting point. So you know what is melting point? Melting point is the temperature at which the element melt. So that is called as melting point. And here melting point is represented in Kelvin. So in the case of boron, it is 2350 Kelvin temperature, and aluminium it is 933 Kelvin temperature, and melting point for gallium is 302.76. For indium it is 429 Kelvin, and for thallium it is 577 Kelvin. Okay. Now in the case of boiling point, so boiling point is the temperature at which the element boils. Yes. So here boiling point is also represented in Kelvin. So in the case of boron it is 4273 Kelvin, aluminium 2792 Kelvin, and gallium it is 2502 Kelvin, and indium it is 2300 Kelvin, and coming to the thallium it is 1746 Kelvin. Fine. So that's it about the different physical properties of the 13th group elements or the boron. Let us see the general trend in the melting point and boiling point in the 13th group element. So generally the trend in the 13th group element, while coming down the group, this melting point and the boiling point will keep decreasing. Okay. So now, there is a slight deviation in that trend in the case of melting point. So in the case of boron, the melting point is 2350. Then to aluminium, it comes decreases. It is 933 Kelvin. Now to the gallium, it is 302.76 Kelvin. So from aluminium to gallium, there is a drastic decrease in the melting point. Now from gallium to indium, it goes, there is an increase in the melting point. So a slight difference can be seen by increase. So it is in the case of indium it is 429 Kelvin, and then again an increase to thallium, that is 577. So in the case of melting point, while coming down the group in the 13th group, melting point increases and then decreases and then again increases. Right? So that's the trend there. Now in the case of boiling point, that same trend, the general trend is that while coming down the group it decreases, boiling point decreases. So it is well seen in these values of the Kelvin scale, that is boron 4273, aluminium it is still decreasing 2792, and then gallium 2502 Kelvin, indium again still decreasing 2300 Kelvin, and again still coming down to the thallium, again it still decreases 2746 Kelvin. Right? So that's it about the trend in the melting point and boiling point of the 13th group elements. Fine.